Listening to good music. Let me mute this. All right. Cool. Let me remember where we were last time. I mean, apparently I have this page. I have this page bookmarked, so we finished 14, which is just intro to classes. Seems like, yeah. Because we had this is so yesterday. Yesterday I went out with some buddies at night. Of course, that meant no programming. Annoyingly enough, and the night before was kickball, which I fucking drank a margarita, which was wine apparently, and it messed me up. One drink, so I got home and done. So we're back. I made some stuff in Unreal a second ago. I'm trying to start the process of spending my free time meaning time outside of studying, doing stuff in Unreal to get back into Unreal. The muscle memory is still there for a lot of things. I have an idea of how I want to do stuff, and like what I can do, but there's so much I don't know, and I just need to get better at finding plugins and other features and meshing them together to make real solid products and ideas. So back to C++. Last time there was a question about a point 2D, and it had an X and a Y, and then I think we just added a print function, simple enough, as a either a member function or a free function, a non-member function. But then after we had one that was like an employee that was made with functions, or triad maybe, that was made with functions already, or made with free functions, and we had to convert them all to member functions. And I really didn't want to, because some of them should not be member functions. Like distance2 isn't bad, something dot distance2, and it just takes a reference to the other class object that that we're getting the distance to. But other stuff like I don't remember. Some of them just felt wrong. Let's see. So you had a point CD, two member variables, cool. Yeah, it's easy enough. And then adding distance2 and then calculate. Yeah, that's easy enough. Yeah, also member function. And then question 2. And okay, 2 were conceptual questions. That kind of makes sense, but it was quick enough. Oh! Pimple on the head, very fun. Alright. We're to short program using a fraction short. Yep. There you go. Tiny little piece of chicken between my teeth from earlier. Made stir fry yesterday. I could see dot print being a function. Ah, there it is. Then there's a function called get fraction. You can get the class definition. A non-member function called get fraction. We make that as a member function. I'm trying to remember the use case here. It was either the return value of multiply or get fraction that we were printing. I think we were doing... Ah, that's what it was. So we turned multiply, we made multiply only take one const reference for another fraction because the implicit object was this, hence this pointer is what we're gonna learn, I guess. So we call multiply with another fraction, but that fraction was the return value from get fraction. So it's like, hey, we have a fraction 3/5, right? And we're calling, ow. We're calling, so we have let's just say it's called my fraction. We have my fraction dot print fraction, and then in parentheses, multiply, and then, oh, it is, okay, so it's print fraction. We're printing the fraction that is the multiplication, the product of this, my fraction, and get fraction. So let's say we have 3/5. Okay, we're printing the result of something in another fraction, of this in another fraction. The other fraction is 3/5 again. So we're printing a something of 3/5 and 3/5. We're printing the multiple of 3/5 and 3/5. So we're printing 9/25, and then boom, we're printing 9/25. That's it. Yeah. And then why was the fraction constructor made explicit? It was made explicit. I mean, the main part here is to avoid implicit conversions, but it was because we made it yeah. The best practice is to make constructors that can take one argument explicit, because if it only takes one argument, then the likelihood that the implicit conversion messes up what we're wanting to do is high. Excuse me, or at least is risky. So what do? It was there was a constructor and it looked like fraction, and then it was fraction int numerator equals the default value, which is 0, comma space, int denominator equals default value 1. And the point is that if the user specifies both in the call, it overrides 0 and 1. It overrides both default arguments. If they put in nothing, then it's 0 and 1, so it's using both default arguments. And if they put in one argument, then it's not the second argument, it's the first. It's assumed to be the numerator. So in one constructor, we're handling 3 cases: 2 arguments, 1 argument, and 0 arguments. Which means if someone passes in 1 argument, they pass in a character, or they pass in something that is converting here that maybe screws it up, then we have to make this guy explicit to avoid any implicit conversions. I'm trying to think of an implicit conversion that would actually be risky, that I would want to not, I guess, yeah, to disallow. We were dealing with ints here. I guess long and long, right? Talking integers. Then we could get narrowing conversions, and maybe let's find out if that's a thing. Does it prevent? Okay, I dislike the song now, and it's only because of the lyrics. Maverick gamers, bro. Maverick? I don't like that word. It's boring to me. I'm gonna unlike it and move it just because I thought they were saying my favorite gamers or my favorite game or something like that. Like, yeah, man, I like games too. Makes me happy to hear that. And Maverick? What kind of gay word is that? All right, so if we had we don't need anything yet. We're just gonna do class. We'll just call it test, sure. And X, oops, please. And MX, wake the fuck up. The wine should have worn off by now, apparently not. These are private data members, so we'll just make them explicitly private so it's obvious. Then test, we're gonna make this explicit and it's test in X and Y. Oops. Okay, MX is X. MY is Y. Builds fine. Cool. I'm not used to building so damn easily because I'm used to Unreal Engine where the building was fun. It's gonna be good when it's ready. Got some fruit stuff. All right. So you could create one. We'll create a test called X, whatever. It's fine. We'll pass it 4 and 5. Cool. X is 4, Y is 5. All right. Or M and X, M and Y. All right. Now, but if we make it explicit and I do this big ass number, there it is. Boom. Would it care if it wasn't explicit? So it's narrowing anyways. And it's because of this here. And we can't even do... Well, direct doesn't catch that, right? I'm pretty sure direct initialization doesn't catch narrowings. Oops, sorry. Oh, but this might be. So let's do... What if we did this? Ah, but it has to be this format in order to actually initialize it, though. Damn. Okay, but here we go. What if it's big, 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 big? Still truncation. Okay, never mind. Well, I thought so. Explicit doesn't even help. I mean, it's gonna get caught anyways. I was hoping that explicit would disallow it like that, but no. The hidden this pointer. It seems like the this pointer is the method by which a class's object, or like a class object, is implicitly passed to its data members, or to its member functions. Yeah, because we don't have to use its name in order to initialize its data members from the member initializer list. We don't have to say whatever subspecific name dot m underscore y and then dot m underscore x x y. So somehow the object itself is being passed into those functions. So we haven't discussed the method by which the member functions in a class definition we get the information from the object they are inside the definition of the class of something like that. They're member functions are inside a class definition. Object is created from that class definition. How does the object actually get passed to the member functions in the definition? It's not like the object contains the functions. It's just that it's able to call those like it's like it's part of a namespace. It's inside a namespace kind of thing. It's holding its own value and a lot of stuff. Okay. It's interesting. It's hard to unravel and say accurately exactly. Oh, I need some. Old enough. I ate pretty recently and I waited way too long. I was really hard. I was stuck in Unreal. It's hard for me to get away from work, stuff that I actually want to do. It's just hard. I have to figure out how to keep tapping into this kind of stuff. I just have to do the shit that I want to do, and then it automatically, I'm stuck in it, which is good. All right. Hidden this pointer and member function chaining. Member function chaining, meaning... Oh, I gotcha. I don't see anything super special about member function chaining. Like, I'm assuming this is what it means. God, I'm back in the music mode. I think I've gotten a lot better at doing stuff while music is going on. What the fuck? Excuse me. No invariants. How would I want to do this? I'm trying to think. I want to just do a function and I pass it a number that it gets added to, and then I pass one that it gets multiplied by, something like that. Do I want to return an int or just a num? I think we just return a num. And the print would be helpful too. Well, I guess it would need, I mean, here comes. Oh, the voice is really, really good right here. Nice job. Re-adding that. Let's go. Mm. Fuck. Okay. I think this should work. And I think I could do an explicit crazy thing like this. What if we did that? Hold on. Oh wait, hold. That's not how it works. It's a fucking... Oh, I could. So we could actually do... See, I don't like print in this case. Or it really should just be dot print. That makes more sense. Yeah, it shouldn't take any parameters. It should just print itself. Yeah, that makes much more sense. Okay. So the idea here is we create a temporary num, right? Dot add, and we add something to it. And what we're adding is, oh, it actually hold. You know, sure, we could leave it with numbers. So we could do num, okay, right? We have a number and it's initialized with 5. Or we could say, what do I want to do here? Number, and then I call. Yeah, I guess that's how it is. I'm just trying to wrap my head around the syntax. So we do number initialized to 3 dot add. What are we adding to it? We're adding 5 to it. Dot multiply. I'm multiplying it by 10. Dot print to print the whole thing. Hold. Well, yeah, but these are const references aren't okay. Ah, fuck, because we're creating. Yeah, I guess that's still true, huh? We just want the values. I mean, if I'm using it in this context, because I really don't want to make any copies of it. We do a number and initialize them with 3. Even if it's a constant reference, we can't do it for a function call. We can't do it across function calls. So at some point, we have to just do. I mean, it wouldn't make any sense for these to be a constant. It's fine, sure. No, what the fuck? What the fuck is that? I don't know what happened. Oh, shift. Wait, what? I don't know what I was pressing, honestly. Oh, shift? Yeah, I don't know how that works. Shift delete deletes the whole line, I guess. Yeah, I don't know. It's like the same as Control X in this context. Okay, why did I delete the whole fucking line? Alright, we'll just replace them with ints, fine. The problem though is, oh, but then we can do a num, get num. Hold. Yeah. Hold on. Turning a num. Oh wait, whoops, sorry. Yeah, no default argument. You create a number, it's initialized with 10. So how does that work? So that's a number with 10, and we're creating a temporary object in order to use its function to return. Okay, is that how that works, right? Cool. All right. Oh, the problem is this. This is returning an int. I don't know. See, the annoying part there is that I have to create a num in order to use get num. Why the fuck is it a member function? It's so stupid. Bro, honestly, it just shouldn't. This is just retarded. Why would it be? Alright, where's the music? Excuse me. What? Yeah, you can make some disgusting looking stuff here. Okay. There's a bunch of shit you can do. Noted. I mean, it seems like it makes sense already. I mean, because each call has to deal with, call relates to a specific object. As we call it on the objects, on the objects. We have a number, and then we're doing dot print. Even if it's temporary, we know that it was called on that temporary number. We have simple, simple. It's just called simple one. Then we can do simple.setID and simple.print. We're creating a simple. It has a one parameter constructor. Takes an int. Cool. We have a simple with one called simple. We can get ID and it returns MID. We get set ID to be 2. We can print it too. Give me a second, return the ID to somewhere that needs it. I could have done standard character output simple.getID, or I could have just done print. Call simple.setID too. Well, it knows that, hey, we're dealing with simple. And we're setting it. Makes sense. Yes, and the MID is simple's MID. Can we not have songs that just instantly end? That's so stupid. I'm just pissed off. The food hasn't kicked in yet. Hungry. I really want to eat this fruit stuff here, but I have to wait for it to dissolve enough. It's all just still frozen. Well, finally. I'm bitching out right now. Oh. Oh. Oh, it makes me feel good. It's like a Danimals. That's amazing. Blueberries and passion fruit are just fucking killer. Really, it's actually called this. And so the point is that it probably looks something similar to it has this pointer, which probably looks something like a test pointer called whatever. I'm gonna call it this, right? And it's basically using what's a pointer to an object. So it's really this is MX. Oh, we don't even know. Well, no, this is a pointer to a test. But we can't assign it here. Oh. Yeah, exactly. That works. Okay. We just can't use it here because this is where stuff in here works. This is not. Okay, so yeah, it doesn't work there, but it works here though. What is this little lock that it has? Oh, because it's private. Oh, that's why I feel private. Okay. So it's really something like, well, it's not taking, this is a pointer to itself. It's calling it with its own address. And then it's initializing its own shit there, something like that. Maybe. I'm not exactly sure if that's how the constructor. Maybe that's not exactly how the constructor works. But let's do. Okay. Then we can have void print. Okay. Whatever. It does some stuff. Well, we'll just say. Oh, God. I don't know why that wasn't working earlier. But really, it seems like it's passing itself a what the fuck am I doing? Oh, it doesn't even care that it doesn't have main. Interesting. Oh, because it's having an issue here first. Maybe. I guess not. It shouldn't, but oh. I was surprised why there was milk in the cup. And it passes it in its own address here. It was like create object, call dot something it. That's the same as calling print, and then you're passing it itself, and then this. And so is the point that you're overloading? Do you have an over? Well, there's no way you can overload for each one. I'm just curious how the dot operator lets you call print on it. I don't know. There's no way to know. It's not a thing you can know. Okay. Okay, it's too cold. I gotta fix this shit. Too cold in here. I don't need water. I don't need anything. Shit. Why is it so fucking cold? Isn't going schizo at 74. What the fuck? Oh, fan is on. God damn, I'm stupid today. I haven't eaten food. I'm just a retard. On. Alright. Hidden this pointer. Keyword this is a const pointer. Makes sense. Not a pointer to const, a const pointer, as I just put in the syntax. That holds the address of the current object. Here it is. The question is how this gets into the function. Or I guess that's not the question. If we assume that it just secretly passes a piece of itself, or somehow the function is just tied to the object simple, then the question is how does it know which MID to get? The answer is this to specify. Everything needs to be resolved. Scope, resolution operator, everything. Everything needs to know who's owning what. Makes sense. Alright, I need more music. This is getting extremely boring. This voice is not good. Not in this context, not with the effects that are on it. I did. Well, and if it's a pointer to this object, we don't have to check to see if this is valid. I suppose we could, huh? We could. What is your issue right now? Oh, that'll do it. I was looking at the wrong thing. This is a pointer to itself. Means we access its member via the arrow operator. Okay. The milk isn't very cold either because it was out. Hasn't cooled down yet. Cool. X could have been const too, and it would have been fine. Makes sense. The former is actually. Mm, gotcha. That makes sense. And we're passing it a reference to simple because simple is being changed. Passing it the an argument that will be used to change simple through the reference. Similar to what I was thinking earlier, but a reference is more convenient. Pointer. Oh wait, never mind. Sorry, this is not a reference. No, that's not true. Just passing the address. That was stupid. It's a call, not the ref, not a definition. Static Y, not sure. But yeah, that's exactly how I wrote it. I just didn't static. Static keyword means the function is not associated with the objects of the class, but treated as a normal function inside the scope region of the class. Oh, thank fucking God. So I can have classes that I can just call like that. Oh, thank fucking God. I don't want to have. I want to have things as restrictive as possible, or as I want to delegate responsibility as far down as possible. So if I can see stuff up here, but I don't, but it's only used down here, I don't want to delegate it to the level down. I want to delegate it as far down as I can so I don't have to deal with it, so that I can make other stuff named the same thing without conflicts. So what we want is to say, hey, just like a namespace, we're saying this class name, scope resolution operator, this function, and then it can take whatever, a function called, excuse me, make of this or something like that, so that I don't have to put it somewhere else. Because before, when we had get fraction inside of fraction, it felt stupid, but it would create a higher risk of name conflicts if we defined get function outside the member function. But instead, we can keep it inside and just make it static. And I guess the point of making, I'm not sure the difference of between that and making a data member static though. It was required to be static when we were initializing something. Maybe it's saying that it's guaranteeing that it's not one of the data members that is, oh, that's it. I think it's a similar thing. It means that this data member is not going to be initialized in the definition or in the initialization of this class object. Because if it was, well, that's not how this works. You can't initialize. If we're doing initialization, we're doing initialization. You can't say that, hey, you're initializing 2 out of 3 of these things, and if you happen to not, and there are 4 data members, and if you're initializing 2 out of 3 of them, you can't say that, hey, the last one is automatically going to be this guy. You're just omitting him from the call. We have to say that explicitly, this guy is different, and we are using him to initialize this guy if you don't specify him. Must initialize, and then may, or this guy who is different can initialize him. That's cool. We had to make a static data member in order to use an argument like that. Oh yeah. Oh, mango's too big. Watch this cup fast. I don't want milk to sit in it. I haven't eaten enough. Wait, that's a strap. Okay, better. I'm excited to use static member functions. Really. It seems like there are those friend functions. No, because a friend is a keyword. It's different. Seems like there are static member functions, i.e. functions that I'm not sure when we would want a friend function, because I assume those are not defined within a class. It seems like static and non-static satisfy most of the use cases. Like if we have a function that we want to create a class, we probably want it to be static so that we can just call friend get friend in order to whatever initialize a friend or something like that. I mean, we wouldn't need that, would be a stupid case, but I don't know, most of the cases we're either operating on an existing object or we're creating one, which we might be static. Excuse me. I guess enums are kind of static too. They seem like it because they're it's just a definition within the class. It's not bad, but I'm tired of the effects now. I want raw voices. Except here's the exception. Wish it didn't say this arrow's right there. I wish it just said this, which points to simple, because this points to simple. This arrow is pointing to a data member of simple. Or at least this points to simple and the data member lets us access it. So yeah, I don't think the arrow is needed there. This would be a clearer thing if it didn't say that. Non-static member functions have a this pointer. Excuse me. Non-static, excuse me again, has a this pointer. So if it's static, it's treated as if it's not even related to the object. Well, it's not even being called on an object, I guess. Right? Interesting. Okay. This is damn, a lot of shit left. How many this? Bro, hello? So it looks like simple scope resolution operator. Well, I guess it's, yeah, simple scope resolution operator, simple, parentheses, address of A, comma space, initializer, comma space, initializer, whatever. Just one initializer in this case. And then in the function, it is, or I guess it's, this is initialized to be address of, oh yeah, so it's being passed address of A. So really the constructor has a simple pointer, or a simple pointer that's const, initialized with that address, and this arrow, boom, data member is assigned to be the other argument initializer. A.setID is saying simple set ID, pass reference of A, pass the value that we're going to set this arrow to be. That's a good song. Okay, the voice is just ridiculous. It's insane. I'm curious really fast. She sings here? Bro. Okay. It nope, doesn't exist. Yeah, duh. You just passing the address of A or the address of B. Hello? And even it's just an integer, so it's small anyway. Say this is data, get comes data. Gotcha. Bro, there's no way. Some developers, absolutely not. They're just typing challenge people. Hmm. Yeah. See, here it comes. It's gonna be dot 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 dot. Here it comes. About fucking time. Yes, because this returns standard character output, and then boom. Actually, quite a few bits, buddy. Not several. Yep. Yep. Wait, what? Hold on. Oh, because for the insertion operator, it returns the left-hand operand. Gotcha. So if it returned nothing, that wouldn't work. So we need to return the left hand. Yep. Yes. Oh, and this is doing a non-const reference. It's actually updating the values. Duck. Oh, is the only way you can pass, or the only way you can return a reference from an object from a function is if, or a pointer is if it's valid before the call. And this is valid before the call because the object exists before. Gotcha. We can't just return temporary. Okay. Unless we're copying it by value. We're not. Wait, what? Oh, because we're returning dereferenced. Okay, we're returning by reference in this case. And if we're returning by reference, we don't have to dereference. We can return by reference to just do the dot operator instead of having to do arrows. Gotcha. Okay. Makes sense. I was trying to figure that out earlier. Sure. We're returning a reference that way we can keep modifying it. Makes sense. Otherwise, we can't call it to modify. Yeah, we could only call const member functions to modify a non-const, or to modify a const. Excuse me, class object. Hmm. And this has to be valid. We could do mx, or we could just do. That's not. Yeah, that's nice that we can return a reference to to this. That's great. I mean, in this case, it may as well be static. I think, but we could do but maybe not. We could say let's create a temporary called 5. We do dot add. We add 10 to it, and then we get 15, and then multiply times 100 dot print. That's so much nicer. Talking 1500? Yeah, good. Okay. It's an easy order of operations. Bop, bop, bop. One line. Very, very nice. Fuck, I should have thought of that. Well, I mean, I didn't know how to get a reference itself. I didn't think that. I mean, we don't explicitly pass it, so I guess I wouldn't have known. It's fine. You still could have done. You could have done calc initialize. Well, you could have just done calc initialize with something dot whatever. Like, you could have just replaced this, added calc before here, calc value initialize dot add dot subtract dot multiply dot value or dot get value. Or I guess yeah, we could have standard character output that whole thing dot get value. Would have returned an int. Makes sense. Yep. That would be cool. Oh, so default initialize is one that exists. Interesting. And I guess it's okay with, but isn't that an implicit conversion though? Guess we'll find out. No, because that's null. Oh, because there isn't one that takes no arguments. Oh. Well, if it takes no arguments and it's explicit, then it doesn't matter, huh? Uh-oh, hold. Well, so it would be converting it to blank, I think. Interesting. Okay, so we could prevent that actually with explicit. That's what I was guessing. Hmm. Does it actually do it? Oh wait, well yeah, we're initializing them. Can't do dot because it doesn't return. Well, oh. Well, we could make it return itself, huh? We're dereferencing it, so we're returning a reference. We could do. We'll have 30/30. Nice. Feels good. Cool, so we can just have the object and do nothing with it. Nice. Okay, we do a bunch of stuff to it. We get the value, but then we reset it and then we get value. I'd rather do it dot get value. That'd be nice. Dot reset to get value. Maybe not. This, I mean, this makes more sense. We're explicitly resetting it and then getting the value. Oh, so this probably, this maybe doesn't work if it's a pointer to or hold. It's a pointer to a non-constant. We can't convert a const to a non-const. Right? Something like that. For non-const member functions, hold. Go 4 minutes. For non-const member functions, oh shit, it actually depends. So this is always usable basically. It's to a pointer to a non-const for non. Okay, gotcha. So if we have a const object, we can call some functions, but not. Well, duh, makes sense. For functions that aren't const, this is a const pointer to a non-const value. Okay, meaning exactly. Yes, yes, yes. We already said that. Oh shit. Oh wait. Oh, it is const both. Okay, I thought I didn't read the. I thought it said a pointer to a const. Like wait, what? It could be set to something else, but no. Cool. That makes sense. So if we call the function with this, and we're returning a dereferenced this, and then we call a function that's, well, yeah, I mean, it makes sense. You just have to be aware. Think, hey, I have this object, this class object that I'm calling, and it's const, and I'm calling a non-const class object. But you call a const member function dot a non-const member function. Because the const member function returned a const version. Yes. Okay. We don't have to put const first in the reference thing, though. That's implied. Meaning that in a function signature, and we're returning a num reference, and then we're returning dereferenced this. If this is always, well, in cases where this is a const pointer to a const, don't we have to make the return type still const? Like I can't return pointer to const as a non-const pointer, right? Like if I say a const int pointer, or well, a const int, a reference to a constant called get int, or we'll just say test, and it takes a const int pointer x, and we take this const away, and then we return x like this, get an issue because we're taking the constant and turning it into an int. There's a difference. We're returning, excuse me, an object, a dereferenced const object, but we're actually passing him as a modifiable object. So if we had a class and we didn't have const, it seems like we would need, well, actually no, the const might be, maybe it's implied in the middle const, because if the const member function, okay, all right, well, I'll sort this out later. It's fine. Okay. Errors generated from temp. Okay. Oh, I gotta go. I gotta go bad.